I'm going to compare and contrast these two smart scopes, the Seestar S50 and the Unistellar Equinox. This is an original Equinox, not the Equinox 2. I'm Chris Maher. I've been doing astronomy since I was 11 years old. I've had the Seestar a couple years now. I've had a lot of different telescopes, and I can tell you, I have used this little smart scope more than any other scope I've ever used. Super impressed with it. But there are issues, of course. Got the Unistellar just 3 weeks ago maybe, and I won it in an AAVSO auction. And so I didn't pay full price. And that matters a lot. So the first thing any smart scope has to do, the essential thing, is connect, right? Connect. Connectivity is critical. If you can't connect to your smart scope, it's just a brick. So with the Seestar, you've got right now 3 ways to connect to it. You've got direct Wi-Fi connection with the Wi-Fi hotspot that it makes, which is not a great range, but adequate. Then you've got station mode, which is wonderful. I'll run it out here in my yard, and it connects to the Wi-Fi in my house. I sit in my kitchen, 0 connection problems, right? And then they've got the telescope network now that you can connect. The satellite, or the telescope has to be in good Wi-Fi range of something. Connect to that, and then you can be anywhere and connect to it. And right now that's free, the telescope network, but eventually I'm sure they'll start charging for it, and there'll be some pricing structure. And we know ZWO's pricing is usually good, so I'm not too worried about that. And remote operation, wonderful way of connecting. I've used it, and I was impressed. It's slower than direct Wi-Fi connection, and of course if you're close to the scope, sometimes I'll go out in the desert and I'll set the scope up literally right next to the truck, and I'll sit in the truck with the engine running sometimes because it's cold, and I have 5G to the telescope, so that's pretty good. Over station mode, it only works at 2.4 gigahertz, which is a little slower, but still very nice to be able to sit in your house and use it. With the Unistellar, you've right now got one way of connecting, and that is the direct Wi-Fi connection. Now the Wi-Fi range on this is better than the Seestar, but still, once you go inside, it can be spotty. You can have this out in your yard, and if it's too far away, you can't be 100% sure of the connection. There's a way that is being created to connect to it called SkyMapper. It's a separate traffic. There's a separate company called SkyMapper that is working with Unistellar to essentially create a telescope network. Now the SkyMapper module or device, I just looked at it on the web, and it was $350. So, but that would give you a second way of connecting. But this doesn't have station mode, and that would be super nice because connectivity. Just give us more ways to connect. That's what I'm looking for. When they do have the SkyMapper set up, and I think it's in beta now, or may still be in alpha, you'll be able to operate it from anywhere, and you'll be able to let others operate your scope, and you'll earn tokens, and then you'll be able to use those tokens to operate other people's scopes. Say, example, in the southern hemisphere, to observe a comet that you can't observe from where you are. That's cool. But still, there's going to be an economy, and I imagine there'll be an economy with the Seestar telescope network as well for telescope time. All right, the app. The app, second most important thing, any smart telescope, since you're using it on the app. Very impressed with the Seestar app. As far as I'm concerned, the Seestar app is superior to the Unistellar app. However, there's always a however. Like Unistellar used, I don't know, slightly odd language, like enhanced vision, right? That's stacking. Sensor calibration, that's dark frames. So okay, whatever, you can get used to that. Autonomous field detection, that's plate solving, right? Telescope orientation, that's the initial plate solve for the scope to figure out where it is in the universe. You know, okay, I can get used to that, no problem. What they don't give you in the Unistellar app is a planetarium view. They give you a catalog view of the objects you can see, and they're sorted in some logical order, like the stars are sorted by brightness. Great, the stars that are visible right now, if you want to pick the brightest one, if you can see it. See, I have a lot of trees back here, so I look around and I go, what star is that? And if I don't know right off the bat, I get stellarium out, I look at it and go, oh, that's Capella. Okay, go to Capella. Easy enough. That's to focus. We'll talk about focus in a little bit. But the big thing that Unistellar doesn't give you is the star map, the sky atlas, and that is such a nice feature. I've used it a lot of times in outreach with the Seestar, showing people how I can frame things up, and it's just amazing, really quite amazing. Now, on the other hand, Unistellar has some really neat features that Seestar doesn't have. I love their joystick mode, because when you touch the joystick, you've got fast or slow speed, and when you touch a direction, you feel a haptic feedback in your phone. It goes tick, 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 tick to your fingertip, it lets you know I am commanding motion. Doesn't mean the telescope's moving, but that's a positive feedback method that I just love. Okay, here's a big thing, a really big thing in my opinion. Equatorial mode. You can see I've got the Seestar in equatorial mode. Once I went to equatorial mode, I never went back. Well, okay, not never. Sometimes if you're demoing or something, you might want to go to Alt-Az mode. But mostly, this is when I'm using it. I shoot almost exclusively in equatorial mode. So, and you simply do not have that option. With Unistellar, there is no option for equatorial mode. Okay, now all that said, the Unistellar app is entirely usable. It is entirely passable. They have a kind of a neat thing in the Unistellar app, because some of these Unistellars have a video eyepiece. They put a little video screen and an eyepiece so that people can have that eyepiece experience, and people want that in outreach big time. People want that. They don't want to look at an image on a screen. They look at images on screens all the time. They want to be amazed by looking at an eyepiece. I get that. But with the eyepiece, you only get a round circle of video view, and that helps if you're on an object, on a Orion or something, and it helps cut off the field rotation, right? That you're automatically going to get with the long exposures on an Alt-Az telescope. Yeah, the Unistellar app is entirely passable, and I've seen way worse. Okay, huge difference: 114 millimeter objective versus a 50 millimeter objective, and that, you can do more with more photons, right? Focus. The Seestar has autofocus, built-in autofocus. This has a dial on the bottom that you turn to focus. Now, it does include in the lens cover a batten-off mask. Not a great batten-off mask. I don't know why they made the slits so small, but okay. It's a batten-off mask, and yeah. Now, when you do science missions with the Unistellar, you have to go out at the end and put the lens cap on so that it can take dark frames. With this one, it has a built-in filter, and one of the filter positions is dark frames. So you can and it auto captures its own dark frames, which is amazing. Also, the Seestar has a provision for taking flats. I haven't seen any provision for taking flats with this scope. So, to me, I consider flats to be the most important calibration frame because I do photometry and you need flats for photometry. So now, let's see. This comes with a solar filter. I mean, ships with a very, I mean, the best film solar filter I've seen. And then you have to manually put it on the front. This does not come with any kind of solar filter. You can make one. You can 3D print one, make your own, buy one, whatever. But it'll do the sun. It just doesn't come with a filter. Of course, this comes with a built-in light pollution filter. It's a rough, wide band, like a 20 nanometer hydrogen and oxygen filter. But that makes so much difference. It gives you so much more contrast on emission nebula. So that's really wonderful. Field of view. This one is more, the Seestar is more than double the field of view of this scope. Now that's not the problem you might think. I mean, you still can't get Andromeda in this, but you can get the full moon and the full sun. You can't do the full moon or the full sun. Most of it, you can get most of it, but not the full moon or the full sun with this. It's something like, what was it? Less than half a degree by half a degree, and this one's a 1 in, let's see, what is it? 1.3 degrees by 3/4 of a degree for this one. So, and the camera's really no comparison. This has a 2 megapixel camera. This comes with a almost 5 megapixel camera. That's the Equinox, and the Equinox 2 has a 6.2 megapixel camera. So the camera is superior in the Unistellar. Oh yeah, here's the field of view. 27 arc minutes by 37 arc minutes. So really, really small field of view on this one. What else? Equatorial mounting, I talked about. Field of view, I talked about. Now, here is where the Unistellar shines. Science missions. Science missions. It's amazing. You can do things with this scope. I really wish ZWO had the science support that this one does. I think they must have hired a bunch of postdocs or something, because, and then you send the data in, and they have a bot that processes it. A few days ago, I went out and got an asteroid occultation with this. I've never done that. I've done a lot of different things in astronomy, but I've never done that. And I drove to the center of the path, got up at midnight, drove out to the center of the path, about 45 minutes from my house, got set up, focused, and I grabbed video for 10 minutes, 5 minutes before the scheduled time to 5 minutes after, and I sent it in, and a couple days later, I checked their science webpage, and positive detection. And I didn't see, because it was only 2/3 of a second that the star blinked out and came back. So fast, I couldn't even see it. But they definitely detected it and turned it into a format that, that you could obviously see. So I was really jazzed about that. I've done a bunch of photometry on cataclysmic variables, supernova with this, sent it in, they processed the data. Amazing. I just wish, ZWO would do something like that, because that's very satisfying to take data and then submit it to a science database, and hopefully someday some scientist will use it, some professional astronomer. They call it citizen science, which I hate that term. I mean, you're doing science or you're not doing science. Okay, distinguish between people who get paid to do it, who get grants, and us amateurs who just do it because we love it, all right? That's still science. All right, so yeah, I've got this one. They have exoplanets, and people are submitting. I've looked at their page. They have a Slack. People are submitting data. They're catching exoplanet transits with this scope. And the comets, cometary positions, they have like a Earth Defense Network thing where you're basically taking positions on near-Earth asteroids. That's pretty cool stuff. Okay, size. Obviously, this has a huge advantage in size and convenience. The case for this, I bought it's not a Pelican case, it's like an off-brand from Pelican. It's enormous, but it fits the tripod and the scope. This case isn't this big, it's a tiny little case, it's wonderful. Size, weight, this is so much lighter than this. So one of the things I've learned in astronomy is the more convenient it is, the more you'll do it, right? If it's convenient to run your telescope, you'll do it more. If it's inconvenient, if you have to carry weights and carry the tripod and set it up and take 20 or 30 minutes to get all stacked up and aligned, you'll do it less. Whereas if it's easy, you'll do it more, and that's one of the reasons I've used this scope more than any other. I've got it on an old Bogan video tripod here, so I don't have to use a wedge. I just tilt it to the angle that I want, and it works great. All right, collimation. This is a refractor. You don't have to collimate it. This one they make collimation as easy as I've ever seen. There's only 2 adjustments and the back, and you point at a bright star and get it centered and defocus it, and it only took a few minutes to collimate this, but you still have to collimate. So it's a reflector, so collimation, slight weakness, but it wasn't really that big a deal. All right. So yeah, that's. I mean, this one has the IMX 462 sensor, 2 megapixel. It's amazing if you look on the Facebook group what people are doing with this scope, and people are doing some science with this scope. They've got photometry, a little bit of photometry, asteroid tracking, spectroscopy. It's quite impressive what this little scope is doing. But science-wise, to a large extent, it's because Unistellar supports this one. Which one should you buy? What do you want to do? Pretty pictures? This one's better because of the field of view, because of the ease of use. You want to get, 39 hours on a target, you're more likely to get it with this one, right? This one, if you want to do science, if you want to contribute to science, do science missions, hands down better, all right? But, and then ease of use, this one wins. I love them both. They're both great, and we are so lucky to be in amateur astronomy right now. These things are revolutionizing amateur astronomy and bringing people in that would never have maybe done amateur astronomy before. Because what? They're young people who are used to looking at the world through a screen, through their phone, and that's how you operate these things. Thank you.